Welcome to KTU Maths, and today in this video we are going to learn how to find the limit of a function, and this class is of basic level. Now without further talking, let us get on to the portions. Let us look at a function now. The function we have here is x squared plus x, and we put the limit x tends to 3. So what we have here, the function is x squared plus x, and we have put the limit x tends to 3. And that means that when x approaches 3, f of x will also have a value. Now let us check what is the value. Now what do I mean when I say x approaches 3? I mean that x will approach 3 like 2.8, 2.85, 2.9, 2.91, 2.92, and it will approach 3. That means that it will become closer and closer to 3 until it becomes 2.9999 and so on. But it will not reach 3. But we can find the value of f of x by many methods. Before going to the methods, let us check a short definition of limits. This is the definition of limit. As input variables approach to a value, the function, here it's x squared plus x. And what is the input variables? Input variables is x. Here only one input variable is there. And when input variables approaches a value, the function will also have a value. And this in mathematics is called limit of a function. Now let us check the methods to find limit of a function. The first one is by direct substitution. Now let us take the function that we have looked right now. We can put the value of x is equal to 3 in both these and find the result. We have to put the value of x is equal to 3 in f of x. Then we will get the answer 12, and I will show you how. We can put the value x is equal to 3, x squared plus 3 squared plus 3. That will be 9 plus 3, and it will yield 12. That is how it became 12. Now what about functions that will yield 0 by 0 while substitution? These type of functions are called indeterminate forms. Such type of function cannot be found out by direct substitution. And what will we do for that? And that's what I am going to teach you next. Okay, this type of functions can be called as indeterminate forms, and it can be better solved by Lopitals Rule. This is the name of a mathematician. But before going into Lopitals Rule, we can look at a note. Here it said that when the numerator of a function is a non-zero value and the denominator is a 0, the limit will be infinity. Now let us check it. Limit x tends to 0, 1 by x will be 1 by 0 when substituting the value of x, and 1 by 0 is infinity. That's what we understand. In some field of mathematics, 1 by 0 is also called not defined. But here in the field of limits, it is infinity. In the next method, we are going to learn factorization and cancelling. Look at another function we saw right now. This function, while substituting with x equal to 3, will yield 0 by 0. So substitution is not the correct method to solve this type of rational function. Rational function means a function that is a ratio. So what we have to do is we have to try to factorize the larger terms and then try to cancel it with the denominator. Now we can do it. Now we can factorize the numerator and cancel it with the denominator. We can factorize it. X square minus 9 can be factorized as x plus 3 into x minus 3. And how did we get it? We got it by a simple identity. I will write the identity now. A square minus b square equal to a plus b times a minus b. This is the identity from which we factorize the numerator and we put the denominator as such. Now we can cancel the terms. We cancelled it and we got this term only. Now we can substitute the results and we got 6. Maybe some of you haven't understood it clearly. I will show it now. X square minus 9 is x square minus 3 square. Then it can be factorized as x plus 3 times x minus 3. That's how we got it. Now I will rub it. And what about functions that cannot be factorized and cancelled? Here we use Lopitals rule. And that's what we are going to study in the next portion. In this portion, we are going to study Lopitals rule. This rule is the easiest method to solve indeterminate forms, that means 0 by 0 or infinity by infinity forms, and find its limits. This method is the easy method to do that. And let us check a question. By substituting the value of 3, we will get 0 by 0 indeterminate form. And we know that 0 by 0 and infinity by infinity are called indeterminate forms, and this can be very well solved by Lopitals rule. And L'Hopital is the name of a mathematician. So we can apply L'Hopital's rule now. This is how we apply L'Hopital's rule. We have to differentiate both the numerator and the denominator with respect to the variable. Here it's x. We can differentiate it now, and we have, after differentiation, we get this. And I will show you how to differentiate it. D by dx, x square minus 9 equal to d by dx x square minus d by dx 9. Differentiating x square, we will get 2x minus differentiating a constant, we will get 0. D by dx x minus 3 will be, differentiating x we will get 1 and differentiating a constant we will get 0. And that's how we got this result. And after coming to this step, we can straight away substitute the value and get the result. Here it's 6. By the previous method we got 6, and by doing L'Hopital's rule we got 6. So the answer is the same. Another method through which limits can be solved is the multiplication of conjugates. Let us check a question. Here in this function, when 9 is substituted, it will yield an indeterminate form. It is true that this function can be solved using L'Hopital's rule. That is true. But it is not only through L'Hopital's rule that we can solve functions and solve limits. Here we have to multiply the numerator and denominator of a function with the conjugate form, and we should do in such a manner that it facilitates cancellation. Let us check how. Suppose this is the function, and for cancellation we have to manipulate this equation and multiply it with the conjugate form. We can take the conjugate form of this function. We have taken it, and we multiply both numerator and the denominator with the conjugate form, and the result is this function. I will show you how the result is obtained now. 3 minus root x times 3 plus root x equal to 3 square minus root x square according to identity. It will be 9 minus x. This result is written here. I hope you understood it. Now I am going to rub it. Now in this equation we have to cancel the common terms. I cancelled it, and after cancellation we will get this result. And at this point we can very well substitute the limit and find the value. And this is the method of multiplication with conjugate form. By this method also you can find the limit of a function. And we can go to the next method. Okay, the next method is trigonometric transformation, and it can be used for trigonometric functions. Let us look at a question. 1 minus cos theta by theta, and we have to substitute theta equal to 0 here. By substituting it, we will get an indeterminate form. Now I will show you how this problem can be solved out by Lopitals Rule. Limit theta tends to 0, d by d theta 1 minus cos theta by d by d theta theta. We can solve it now. Limit theta tends to 0 minus of sine theta, that is the derivative of that function, by 1. Means limit theta tends to 0 sine theta, and it will yield 0. 0 will be the answer by Lopitals Rule. But it is not by Lopitals Rule alone that we can solve this function. We can also solve it by trigonometric transformation, and that's what we are going to study here. First, let me rub this. We have to multiply the numerator and denominator with a function to manipulate the trigonometric equation. That means that by multiplying 1 minus cos theta with its conjugate form, we can arrive at some other equations. By multiplying 1 minus cos theta with its conjugate form, we will arrive at 1 minus cos square theta. What is 1 minus cos square theta? 1 minus cos square theta can be written as sine square theta. And from where did we get it? We got it from this equation. This equation is same as sine square theta plus cos square theta is equal to 1. This equation can be rearranged to form this equation, and here sine theta can be substituted to this, and we arrive at this equation. Denominator is unchanged. Now let us check the next step. In the next step, we segregate each terms. We take limit of the segregated terms, that means each terms, and arrive at a conclusion. And here the answer will be 0. 0 will be the answer. And did you notice that here for this function we have to use Lopitals Rule to find out that? So we understood that by using trigonometric transformation also, it is a bit difficult to obtain the result of a limit. So to find the correct result of an indeterminate form, Lopitals Rule is the best method. It is a bit lengthy one, as you can see here. That was all for today, and thank you for watching this video, and also check out other videos. Thank you.